graphs that look like graphs that look like 3D shaped graphs. Am I right?
We are not doing functions. We are done with functions. This is another thing.
Okay, different topic. Okay. I'm just thinking trapezoidal rule. Okay. Well, so would you say the topic is a simple topic? How is it? How are you finding it?
Not too bad.
Okay. How is your teacher teaching you? Is she deriving the formulas, or she will just give you the formulas and then you will apply it to a question?
Well, it's not really. It's just there's a formula for it, but you just have to.
Mm,
You just have to sub in what the question is asking.
okay. Okay, that's nice. Okay. So let me know when you've sent the stuff that you're screenshotting.
Mm.
Okay. Are you still sending more? Or we can start with these ones.
I will just send two more.
Okay. All right. Okay. I think this is okay. Mm, okay. I see orbitals, and I guess they're probably trying to explain using structures, chemical structures and stuff like that. IS 1s to 2s to 2p6, 3s to 3p6, 3pd, and so on and so forth. Okay. Hmm. Okay. Ah. This thing reminds me of so many things. So many things. Okay. Okay. All right. Let me share my screen. Do you want, can we start with this?
Mm. Which one?
Hello, goodness. The one that you sent so far. Can we start with this?
Yes, sir.
Okay. All right. So I'm going to share my screen now. Okay. If I want to annotate, I think I can annotate on it. So I'll just share only where my mail is. Okay. Can you see my screen now?
Yes, sir.
Excellent. Okay, I hope you didn't do too much on your computer at school today.
That's not really.
Okay,
Mm.
all right. I know our class will not be too long. Let me even check how much battery power I have left. Okay, let's see how far we can go on this. Okay, so these are the definitions, and if there's anything I can tell you boldly from the start, just see oxidation and reduction as word and opposite. Word and opposite. Then something interesting happens, and that is that in every reaction that you call either an oxidation reaction, well, typically, okay, let me not say every, right? Let me just say most, okay? You can
Okay.
establish where oxidation is happening and immediately imply that if oxidation is happening and one is can be boldly called an
Okay.
oxidation agent, then there is something else that is reducing the oxidation agent, and that one is the reduction agent. Okay, so let's look at that first example, right? I'm happy that it's like this. It's quite straightforward. The only place that may look challenging is when you're not sure what is happening. But if you look closely, I'm sure you will see it. So the first one is quite straightforward. Addition of oxygen. For instance, this is a very popular equation. Carbon plus oxygen. And there's something I always say, right? Always remember that whenever you're dealing with a gas and you're writing down the equation of that gas, always remember that what do you call it? The atoms of that gas never stand alone. In other words, you will always see oxygen as what? O2, not just O alone. Okay, so I just thought to say that so that we would take note of those little things. So this is oxidation. Carbon gains oxygen, therefore the carbon is oxidized. Okay, if
Yes,
you're
sir.
looking for an oxidation agent here, then the oxygen itself is the agent of oxidation. Then if you look at on the side of reduction, reduction is saying is the opposite, removal of oxygen. So this guy had oxygen, copper, that thing is copper one oxide, yeah, or yeah, okay, yeah, it's copper two oxide, sorry, copper two oxide, okay. So
Yes, sir.
I'm guessing the names because they did not really say the names here. So the actual correct name is copper 2 oxide. So that copper 2 oxide loses the oxygen that makes it an oxide in the first place to what? The hydrogen gas which reacted with it. That's H2. And that now left us with what? Copper standalone with H2O, water. So of course, I'm sure you can imagine how this kind of chemical reaction will happen. By the time the reaction is over, you will be seeing if heat is released though, if heat were to be released, then you would see water forming as droplets on the container where the reaction happened. So this is removal of oxygen. And so you can say that the copper 2 oxide was what? Reduced. Okay, so that's quite straightforward. Reduction. Okay, removal of oxygen. Of course, if addition of oxygen is oxidation, then removal of hydrogen will still be oxidation, like the flip side of oxidation. But this time now we're referring to hydrogen. Okay, and of course, remember word opposite, reduction will be the opposite of oxidation, which is addition of hydrogen. But let's look at what is happening there. So hydrogen was removed from hydrogen sulfide. Okay, so that's what you can see that is happening there. That's what they are saying, that the sulfur loses hydrogen. Therefore, sulfur is oxidized because it lost the hydrogen to what? Chlorine, right?
Yes, sir.
You know the one I'm talking about, right? I'm talking about this side, removal of hydrogen. Okay,
Yes, sir.
all right. So now let me ask, is there any of these definitions that you have a challenge with understanding?
Mm,
Is there any of them that you have a challenge understanding?
no, not really. But no,
Okay, so you've looked at all of them, right? The four of
yes,
them,
sir.
addition of hydrogen, carbon monoxide gains hydrogen, therefore the CO is reduced. And of course, as carbon monoxide gains hydrogen, uh, the one that makes it to gain the hydrogen. Okay, it's not even okay. This one is not a case of oxidation and reduction happening at the same time. Okay, but it's fine. Addition of hydrogen, removal of hydrogen. Okay, loss of electron, gain of electron. Hmm. Zinc is oxidized. Copper gains. Loss is oxidation. Low level. Okay. Gains is reduction. Okay. Hmm, reduction is gain. Okay. So the what do you call it? There's an acronym here for you. Do you understand the acronym?
Mm, yes.
Oil rig. It's quite an interesting acronym. In fact, the first time I saw it, I was wondering what is oil rig doing here? So did I even? I'm not sure we had an acronym for remembering this. I think I just found my own way around it. Anyway, yeah, but it looks good. Oil rig, oxidation is loss, reduction is gain. That's for electron transfer. Oxidation is loss, reduction is gain. Okay, that's an interesting one. I like that. Oil rig. So I think I can adopt it too. It sounds good. But if you notice what I was saying back then, I said something like O level. O level, that's ordinary level. O for oxidation, level L for loss. So that's loss of electron. Then I think I found something for the RG. But anyway, if you understand this acronym, you know, one thing about studying, and I would say not just chemistry, but I think even in some aspects of physics and, well, maths in a way, you find that you have to come up with acronyms yourself. But like in this case, they provided an acronym for you. So um, oil rig is very much related to chemistry. So I believe you would remember that what's going on there has to do with um, a science concept, and in this case, not just any science concept, but oxidation and reduction as it relates to electron transfer. Okay, so this last one that says oxidation number is increased, right? I'm trying to look at it in terms of yeah. So it makes sense. So if you look at it carefully, right? Oxidation number increasing from 0 to +1. Let's look at what happened in the case of loss of electron. You know what I'm trying to do? I want to link number 3 and number 4 together. What I mean by linking them together is they are kind of implied that if you look at number 3 very well, where it says loss of electron, you look at the one that is being oxidized, zinc, its oxidation number on the left hand side of the equation was 0. But on the right hand side, it has lost 2 electrons. That means it has 2 protons more than the number of electrons inside it. So that's why it has a 2 plus on it. And that's the reason why it's said to be oxidized, because it lost 2 electrons to acquire that +2 charge. So it went from 0 to +2. So that's an increase in oxidation number. On the flip side, for reduction, copper, which is the guy reacting with the zinc. Okay, I think this is a very perfect example. So one is being oxidized in the same equation. The other one that is causing the oxidation to happen is being reduced. Perfect. I love this example. Perfect example. So look at it. The copper gains 2 electrons. Therefore, the copper is being reduced because it was going from 2 plus, where it was having 2 extra protons that do not have any 2 electrons to balance it out, to the right hand side where it has collected those 2 electrons from where? From zinc, and it has now become a stable atom. Its oxidation number now is 0, if you like. So it has reduced from 2 plus to 0, or +2 to 0, which is perfectly okay. So anyway, I don't want to confuse you. If you understand the connection that I just established now, you will see it clearly how number 3 and number 4 are well related. Okay, so okay, so causes another substance to be oxidized. Okay. So I think this has basically explained what you said, that the oxidizing agent is always reduced. Yes, by the other one. Reducing agents will always be oxidized. That's a good one. Okay. All right. So okay, so these are supposed to be questions that we can work on, right?
Yes, sir.
So have you done any of them?
I think they have been it at some time.
Okay. Okay, this first, from A to H, you have done these ones.
Yes, sir.
Okay. So which ones have you not done? Okay, I was just looking at this example. Okay, there are two examples here. Okay, Okay. Hmm. Okay. So which one would you need an explanation for?
Mm, you know how they put two brackets minus one under the
O-
period table.
Okay, this one are you referring to this one I'm looking at?
You know, part of the questions, some of the questions, the
Uh,
one above,
okay, I should go back to the ones above.
yes,
Okay.
yeah,
This one.
yeah,
Okay, so what happened?
like the two FE two plus, cause the way my teacher like do the equation is sometimes I don't really understand, cause I just don't really understand how to solve some of this.
Okay. Okay, so um did she follow the examples that she gave here, or is it different for what she gave here?
I don't even know. She just solved it like, but I think she probably used the examples to solve it.
Okay. Okay, so okay, let's look at this one. Let me know how you did this particular one. Me, I want to believe that she would be flexible in her grading of this, because people can come at it from different angles. So let's look at this first one. How would you have done this first one?
Mm.
Is that which one is being oxidized and which one is being reduced?
Uh, the O is being reduced
Okay, the O is being reduced.
and
Okay,
the T the T car is being oxidized.
the calcium.
Yes,
Okay, so the calcium became the calcium was at zero this thing before, because it didn't have any number there. So by the time it got to the right hand side, it became 2 plus, right?
yes, sir.
Because it lost 2 electrons to oxygen, which gained 2 electrons. That's 2 minus, right?
Yes, sir.
So I think this agrees with our definition. Loss of electrons is oxidation, gain of electrons is reduction, right?
Yes.
Okay. So so is there another way you are suggesting that she does it, apart from like this that we just did it?
Yeah, there are some, maybe the new ones are, there are some that she,
Hmm.
maybe as we go on, I will just tell
Hmm.
you.
Okay. Okay. All right. Uh, but this particular topic is quite an interesting topic. Sha. Me, I would say, at least I can speak for myself. I think it was one of those topics that we enjoyed or that I enjoyed back in school. Um, Reduction, oxidation, and all that. Okay. Okay, this is mathematics. That's the old one. Okay. So now this example 14.1, right? If one looks at it, one needs to be careful because it's like what they call it, two halogens. The halogens here are iodine and chlorine. It's like they're just trading places. The chlorine was standing on its own, you know. The potassium didn't look like it was changing. So I'm thinking the potassium did not really change. So we cannot say either oxidation or reduction happened anywhere there. But yeah, if we look at the other one, um, the oxidation and reduction would have happened between chlorine and iodine. So chlorine was zero, its oxidation number was zero on the left hand side. By the time the chemical reaction happened, its oxidation number became -1, right? And then iodine seized the opportunity and now lost two electrons, right? It lost those, no, it lost just one electron, right? Yes, it lost one electron to become stable iodine, as we have it there. So, if oxidation is the loss of electrons, then we can say that um, that was oxidized. So I think yes. So we can see it from that diagram there, that annotation there. The oxidation is happening to iodine while reduction is happening to chlorine because chlorine was going from 0 to -1, which means that it gained electrons. Okay, so it's possible that we can have some elements that are acting in the that are taking part in the reaction, but they are not oxidation, they're not being oxidized, and they're not being reduced. They're just there. Let me just put it that way. They have a function, of course, but it's not as if they are participating as either oxidizing agents or reducing agents. Okay, yes, yes. So we've concluded that Cl2 must be the oxidizing agent. And since Cl2 is being reduced, the reducing agent must be the that's iodine. Okay, okay. So some questions are quite tricky, so you just have to be careful to take a look at them. Did you understand this example 14?
Yes, sir.
Okay, all right. Okay, that's fine. Okay, so just checking this out. Um um these ones that you said that you did. Um A to H, that's exercise 14.2.
Yes, sir.
Let me see the requirement. It said by showing the electron loss, again, which species is being oxidized and which is being reduced. And of course, it now says show the oxidizing and reducing agents in each of the reactions. Okay, 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 okay. So when you are doing it, did you fulfill all the aspects of the question? Did you meet all the requirements of the question?
Mm. She just said we should do ACE. Just keep one.
Oh, okay. Okay, do A, C, E, G.
Yes.
Okay, okay, I get now. I get now. Okay, that's a nice one. Okay, all right. Um, so have you turned it in?
Which one?
The one she said you guys should do.
Yeah, this is January or I think early February. This
Okay,
this notes.
okay, okay. I
It's
get,
been a
I get.
long time.
Okay, I get you. I
Right
get
now
you.
we are doing experiment titration for oxidizing iron.
Okay,
So there
for
is a lot
that.
more.
Mm, okay, so you guys are doing the practicals now.
Yes, sir.
Oh, that's interesting. Okay, okay, okay. That's fine. So, would you say that with the practicals, those concepts on paper kind of come alive?
Mm.
So, we are seeing color changes.
Oh
We are
yes.
seeing, yes. So, for instance, let me see if I can remember. Copper has a characteristic color of blue whenever it's in a particular oxidation state. Can you remember any of the practicals that you did and the things that you observed?
Uh, it's just wait. It's like when we use you see potassium in a burette to find
Okay.
the
Mm-hmm.
uh, and then we use HCLs and then
Okay.
I remember there was a time we were using iron tablets to find the solution.
Oh,
We would
okay.
like measure and then grind it and then
Mm-hmm.
mix it with diluted water.
Okay. Okay.
And there's a picture for it. Maybe I will send it.
Okay. Okay. A picture. Okay.
Yeah.
Okay. All right. No problem. All right. I think I'm running low on battery, but it's fine. Anytime if you can send it tonight, as soon as I have power on my battery on my laptop again, I will check it. Okay.
Okay.
Yeah. But then I know like you said that this thing was a long time ago. Um whenever you can, Sha, you can just make out time to do the ones that you skipped, just for practice sake.
Okay, sir.
Mm. Okay. All right. So I will can meet we'll meet on Thursday at same time, 5:30 your time. So that will be 6:30 my time.
Okay, sir.
Okay. All right. So if there's anything apart from the picture that you want to send that you wish to send to me, you can send it before then so that we can discuss it.
Okay, sir.
Okay. Oh, all right. So enjoy the rest of your evening.
Okay, sir. Thank you, sir. Okay, sir.
All right.